Hi, I'm Chris Teutsch, Forage Extension Specialist at the University of Kentucky's Research and Education Center in Princeton, Kentucky. And this is part 3 of hay quality, defining, quantifying, and supplementing. In this part, we'll be talking about the results from our regional hay contest. One of the things that we do in Kentucky that's kind of unique is that we have some regional hay contests. Last year we had a contest in Eastern Kentucky, Central Kentucky, and South Central Kentucky. And in that contest, we had 1,127 samples entered. This is an agent-driven program, so the agents collect the samples, log the information in, dry and grind the samples, and then deliver them to me. I analyze them in my lab, and then summarize the results and select winners for each of the different categories. What I want to do now is share some of that data with you. And the first one is a summary of crude protein. So let me tell you how I have this graph set up. On this graph, we have the constituent crude protein on our y-axis. On our x-axis, we have our categories. We have grass hay, baleage, legume hay, mixed hay, and then average. On the bars, we have a number, and that's the number of samples in that particular hay class. So for example, grass hay had 528 samples, baleage had 95, legume hay had 55, mixed hay had 449, and altogether we had 1,127 samples in the whole hay contest. The other thing I want to point out here is we have 3 dotted lines. The first dotted line is a growing animal, so a 450-pound steer, and that's their protein requirement. A lactating cow, that's their protein requirement, and then the bottom line is a dry cow. You'll notice that the dry cow has the lowest protein requirement. So what I want to point out from this graph is that all of the hay classes, on average, did well for crude protein. Generally speaking, in grassland ecosystems, it's not protein that's lacking, it's energy. And that's what we'll show you in the next graph. So generally speaking, all these samples, on average, met the requirements of a lactating brood cow. So this next graph is set up in the same way, except we're looking at total digestible nutrients, which is the measure of energy in that hay sample. And then again, we have our classes across the bottom. And then we have our line for a growing animal, a lactating animal, and a dry cow. As you see, on average, none of the samples except for baleage and legume hay met the requirements of a lactating cow. Our grass hay was below that, about 56% TDN. Mixed hay was a little bit higher on average. We were somewhere around 57% for our crude protein or total digestible nutrient concentration. So in general, hay is going to be short on energy, and that's what this graph is showing. When we add legumes, we're going to increase the hay quality. When we make baleage, we tend to increase hay quality because we're able to cut that hay on time. So this is the percent of samples that would meet the protein requirements of a lactating brood cow. What I want you to notice is that about 70%, 70 to 75% of the samples would meet from grass hay would meet the needs of a lactating brood cow. Close to 100% for baleage and legume hay, about 90% for mixed hay. So in general, we're doing pretty good in terms of being able to meet the protein requirements of a lactating brood cow. And remember, she's going to have a higher protein requirement than a dry cow. When we look for the same graph, but the proportion or the percentage of samples that would meet the energy needs of a lactating brood cow, only 14% of the grass hay samples would meet the needs of a lactating brood cow. We're closer to 60 for baleage, 90 for legume hay, which is a good reason to add legumes into hay fields because we're going to increase forage quality when we do that. Our mixed hay was up over 20%, and on average, we're somewhere around 25% of the samples would meet the energy needs of a lactating brood cow. So this tells us that on average, we're going to need to add some energy supplementation to these hay samples. everybody knows what an average is, right? So an average is like having 2 pails of water, one scalding hot, one ice cold. We put a foot in each one. On average, we're comfortable, but it hurts like hell. So this is I pulled grass hay out and put the summary statistics down. I just want to make a couple points with this. First, when we look at the average, crude protein was 11.5%, and TDN was 56.1%. That's great, but we can't really balance a ration on averages. So I can't take results from this hay trial and say you need to add this much supplement to your hay lot, because there's a wide range. Our range of crude protein in the samples in this test for grass hay was 4.6 to 22.5%. And the range for TDN was 39% to 68%. The point that I want to make is that we have got to sample each hay lot in order to design a supplementation program or determine if we need to supplement that particular hay lot. So once we have that information, we have a tool called the UK Beef Cow Forage Supplementation Tool. And you can access it by either Googling UK Forage Supplement Tool or scanning that QR code. And I'm going to blow this up a little bit and show you how to use this tool in the next couple slides. So this is kind of a blown up area here. When we get our forage analysis back, it's going to vary how it looks depending on the lab you send it to. So if it comes back from Dairy One or Dairyland or Cumberland Valley, it'll be a little bit different. But it'll be set up generally like this. So you're going to have a dry matter percent and probably a moisture. And then you'll have your constituents here. I only listed the ones we're going to use in this example. There'll be more in your report. And then they're expressed as fed or as dry matter. And for this tool, we always use the dry matter basis. So what we do next is we take these numbers and we enter them into this tool. So it asks us for the dry matter, we enter 88. It asks us for the crude protein, we enter 11.5 from the dry matter column. We enter 61.6% neutral detergent fiber. We're going to use this to estimate dry matter intake of the animal. And then we're enter our total digestible nutrients, which is an estimation of the energy in that forage sample, which is 56.1. The last thing we have to do here is choose our stage of production. So in this tool, we can choose lactation, mid-gestation, or late gestation. Then we scroll down and we choose the supplements that we would like to get recommendations for. Usually I just hit this select all key and then I hit calculate. And we'll get something that looks like this. And at the top here, it tells us the parameters that we entered. So crude protein, 11.5%, neutral detergent fiber, 61.6%, TDN, 56.1%, and then it gives us an expected dry matter intake as a percent of body weight and as pounds of dry matter. So the way that this is calculated is we take 120, divide it by the neutral detergent fiber, and that gives us this percent of body weight. This is a crude method of estimating dry matter intake, but unfortunately it's about the only thing that we have to kind of get a feel for how much of that hay that animal's actually going to eat. And then it gives us recommendations for all these different supplements so that we can meet the energy and crude protein requirements of that animal given this hay lot. So on average, it was about 4 pounds. One thing I want to point out was that for soybean meal, the recommendation exceeded 4 pounds of soybean meal, so it does not give you a recommendation. When the recommendation or calculation exceeds the maximum amount to be fed, you'll get an NA in that column, and that just tells you that it could cause a nutritional disorder if you fed any more than the maximum recommended amount. So let's look at a commodity mix, and I can buy this commodity mix. It's 15 to 16% crude protein in Western Kentucky, delivered to the farm in bulk quantities for $265 a ton. if I'm going to supplement 4 pounds a day, which is about what this shows per cow, the supplementation cost would be 55 cents per cow per day. If I put that in for 50 lactating brood cows with this hay quality, for 60 days of hay feeding, that would cost us about $1,600 in supplement. For 150 days, which unfortunately some of us are feeding that long, it will cost over $4,000. The point I want to make is that supplementation costs can be high for poor quality hay. So it's always a good idea to think about how we can improve hay quality so that we can limit or eliminate supplement needed when we're feeding that hay.